Hi students, in this class we are going to discuss the concept practice problems of probability. So let us look into the first problem. So the first problem is a coin is tossed 3 times. What is the probability of getting 2 heads? At least 2 heads and at the most 2 heads. Okay, so let us try to understand and how to solve this kind of problem. So coin is tossed 3 times. So what will be the sample space associated with this experiment, this random experiment? Okay, so first time when we are tossing the head, tossing the coin, what we get? We may get a head or a tail. The second time also we may get a head or a tail. Okay, so there are 3 things together in one outcome. Okay, so let us write down the sample space first of all. The sample space is like this. Okay, sample space or the set of all outcomes, okay, shall be taken as S. We shall take it as S, and S will be equal to, let us write it like H, H, H. Okay, all 3 heads, or first 2 coins will give you heads and then the one is tail. Then what we have is head, tail, head. Then what is possible? Tail. Then we have a head and a head. Okay, and then this is T, T, H, T, H, T, and then we have H, T, T, and then finally tail, tail, and tail. Okay, so here what we have is 3 heads. So in these 3 things we have 2 heads and 1 tail. Here in these 3 we have 1 head and 2 tails, and then the final one we have 3 tails, all 3 tails. Okay, now in the first question we need 2 heads. Okay, so what is the number of elements in the sample space? It is 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so number of elements in the sample space n of s will be equal to 8. Okay, there are 8 elements in the sample space. Now for the first question, what is the first question? For the first question what we have is, let A be the event of getting 2 heads means exactly 2 heads. Okay, of getting exactly 2 heads. Okay, exactly 2 heads. So which of these outcomes have exactly 2 heads? Okay, so we can have this one, this one, this one. These are the 3 events, 3 outcomes which have 2 heads. Okay, so we can write this set A as head, head, tail, then head, tail, head. Then what we have is tail, head, head. Okay, first one, second one, and the third one. Okay, these are the 3 outcomes. Okay, so now what we can do is find the number of elements in A, which are the number of, how many number of elements? 1, 2 and 3. So there are 3 elements. So the probability is defined as the total number of favorable outcomes. These are the favorable outcomes. Okay, so probability of the event A is given by say number of favorable outcomes to A divided by the total number of outcomes. Okay, so that is number of elements in A divided by the number of elements in S. Okay, so that will be equal to 3 by 8, which can be simplified using the calculator as 0.375. Okay, clearly it is lying between 0 and 1. Okay, now we shall move on to the next question. The next question is at least 2 heads. At least means, at least 2 means 2 or more than 2. Okay, so the second question is, say B is the event of getting at least, okay, at least 2 heads. At least 2 heads. At least 2 heads means it is either 2 or more heads. It means 2 or more heads. At least means minimum 2 heads. Okay. So, which are the number of elements, or which are the elements here? Which are the elements here? Let us write down the elements. The elements are 2 heads or more heads. So, here we have all the 3 heads. 3 heads possible in this case. Then what we have is head, head, tail. Then we have head, tail, head, and then we have tail, head, and head. Okay, these are the 3 and plus 1 4 outcomes which are favorable to the event B of getting at least 2 heads or 2 or more heads. Okay, so in this case we have number of elements in B or the number of favorable elements to B as 1, 2, 3 and 4. So 4 elements are favorable. So what will be the probability of B? Okay, what will be the probability of B? Probability of B will be given as number of elements in B or number of elements favorable to B divided by the number of elements in the total sample space. So here we have 4 by 8 and that is equal to 0.5. Clear? Same way we can go for the third question of getting at the most 2 heads. Okay, at the most 2 heads. So how can we get that? The third one is, say C is equal to event of getting at the most, okay, at most 2 heads. At the most 2 heads means less than or equal to 2 heads. Okay, less than or equal to 2 heads. Either no head or 1 head or 2 heads, not more than 2 heads. So 3 heads case is not possible. So what we have here is, we can write down the set. Okay, so let us write down the set of events favorable to C. Okay, at the most 2 heads, maximum 2 heads. So 3 heads will not be there. So 2 heads cases, head, head, tail. Then we have head, tail, head. Then we have tail, head, head. Then 1 head cases. 1 head cases will be tail, tail, head. Then we have tail, head, tail, and then we have head, tail, tail. Or no heads cases. No heads cases will also come here. That is all tails, tail, tail, and tail. Okay, so here number of elements favorable to C, number of events favorable to C, number of outcomes favorable to C will be 1, 2, 3, 4, 5, 6, 7. Okay, it is 7 out of 7 elements. Okay, so what is the probability of C? Probability of the event C of getting at the most 2 heads will be equal to 7, or let me write the formula as number of elements in C divided by number of elements in the sample space S, or the total number of events. So this is equal to 7 divided by 8. Okay, so that can also be converted into the fraction as, let me 7 divided by 8, which will be equal to 0.875. Okay, so that's it for this question. So we shall move on to the next question. Okay, in the next question, a die is rolled twice. We know what is a die. A die is a 6-faced cube. So it has numbers 1 to 6 on it. Okay, a die is rolled twice. What is the probability of getting a difference of 2 points? What is the probability of getting a difference of 2 points? Suppose if we roll 2 dice or 1 die twice, so these are the possible outcomes that can occur. Okay, so these are the set of all outcomes, or we can call this as the sample space. This is the sample space. Sample space. Okay, we are writing it in the table format to avoid mistakes. Okay, so what is the probability of getting a difference 2? Okay, here the difference is 0, here the difference is 1, here the difference is 2. right? So we need to collect those elements, those outcomes where the difference comes out to be 2. Okay, so let me count the or mark down here. Okay, this will be 1, the difference is 2. Okay, here the difference is 2, here the difference is 2, here the difference is 2. Okay, same way 3 1 will also give you a difference of 2, 4 2 will also give a difference of 2, then 5 3 will also give a difference of 2, 6 4 will also give a difference of 2. Do we get a difference of 2 in any other cases? So this is 2 minus 2 0, 3 minus 2 is 1, 2 minus 5 is 3, 6 minus 2 is 4. So we are not getting a difference of 2 in any other cases. So we have 8 favorable outcomes. Okay, so 8 favorable outcomes here. So we can directly write down 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements. Okay, so if A is equal to event of getting a difference of 2 points. Okay, 2 points, that will be equal to this set. Okay, this set. If you want to write down, or we can directly write down number of elements in A, because we have an MCQ paper, and so we can directly count from here 1 2 3 4 5 6 7 and 8. Okay, so a number of elements in favorable to A is equal to 8, and the number of elements in S is equal to, what is that? It is 6 into 6, total 36 outcomes. Sample space, number of elements in the sample space S is equal to 36. So it will be equal to 36. So probability of the event A is equal to number of elements in A favorable to the event A divided by number of elements in the sample space, which is equal to 8 by 36, which is equal to 8 divided by 36, which can be taken as say 2 by 9. We can take it as 2 by 9. We can even further simplify into decimals. That will be 2 divided by 9, which will be equal to 0.2222 and so on, which will be equal to 0.222 ... Okay, whatever is given in the options we can select. Okay, next question number 3. So 2 dice are thrown simultaneously. Find the probability that the sum of points on the 2 dice would be 7 or more. Okay, sum of points on the 2 dice would be 7 or more. What will be that? Let us count. Okay, so sum of the two points. Okay, here it is 1 plus 1 is 2. Here it is 2 plus 1 3, like that. Okay, so it should be 7 or more. So let us count all those points where, or all those outcomes where we get the sum as 7 or more than 7. Okay, 7 or more than 7. Let us write down the event as A. Let A equal to event of getting a sum. Event of getting a sum of points more than or equal, sum of points greater than or equal to 7. Sum of points is greater than or equal to 7. Okay, what will be the minimum sum? Minimum sum will be 2 and the maximum sum will be 12. Okay, minimum sum will be 2 and the maximum sum will be 12. Okay, so here we can mark down those points which are favorable to A. We shall mark down those points which are favorable to A. These are the outcomes. Okay, so this is 7. This is also 7. Here also we have 7. Here also we have 7. Here also 5 plus 2 is 7. 6 plus 1 is 7. And everything below this line is also having 7 or more than 7. Okay, 6 plus 2 is 8. So again this one, 5 plus 6, 5 plus 5, 6 plus 5 and 6 plus 6. All these outcomes have a sum greater than or equal to 7. Okay, so let us count them. Okay, so it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. Okay, so what we have got is that the number of elements favorable to A number of elements favorable to A is equal to 21. Okay, so now the probability of this event A will be equal to number of elements in A divided by the total number of elements in S. What are the total number of elements in S? Number of elements in S is equal to 36. We know that sample space of 2 dice thrown simultaneously will give you a sample space of 36. So this is equal to 21 divided by 36, which can be further simplified, and we get it is as 7 by 12, further simplified as 7 divided by 12 will give you 0.583, 0.583, and so on. Okay, so this is the probability. We can choose a perfect answer whatever as per given in the options. Okay, in case if we have some. Next question. What is the chance of picking a spade or an ace not of spade? Okay, first thing is we should understand what a card setup is. Okay, here we have a system of or a pack of 52 cards. So there are 52 cards. So total number of outcomes in this, the chance of picking a card, we are picking one card from a set of or a pack of 52 cards. So what is the probability? One card. So the probability will be 1 by 52, or 52 will be the total number of outcomes. Okay. Now out of them what we have is say 13 spades, 13 clubs, 13 hearts, and 13 diamonds. Okay, here we want a spade. Either it should be a spade. The one card that we are picking should be either a spade or an ace not of a spade. An ace not of a spade. So here we have ace, here we have ace, here we have ace, and here we have ace. Okay. So first thing is that it should be any one of these 13 favorable outcomes, or means it should be a spade. It could be either a spade which includes the ace. Okay, it could be a spade, means it is 13. Number of elements favorable to A will be equal to say 13 plus an ace which is not a spade. An ace which is not a spade. No other cards are favorable. Okay, only aces. A. Okay, out of these 13, one is ace. So I am going to take 3 of them. So total number will be equal to 13 plus 3, that is equal to 16. And the total number of outcomes is 52. So number of elements in A divided by, or we can say the probability of the event of getting a spade or picking a spade or an ace not of spade. Okay, that will be equal to 16 divided by total, that is 52. Okay, 52. We can count, this is 13 plus 1 plus 1 plus 1 will be equal to 16. There are 16 favorable cards. Either it could be any one of the spades including the ace of spades, or it could be any one ace which is not of spade. No other cards. Okay. So 16 cards are favorable. So 16 divided by 52. We can further simplify. 16 divided by 52 will be give you 16 divided by 52 will give you 0.307, and so on. Okay, the answers can be matched. Next question, question number 5. Find the probability that a 4-digit number comprising of the digits 2, 5, 6 and 7 would be divisible by 4. We need to find the probability that a 4-digit number, okay, 4-digit number and it should comprise of the digits 2, 5, 6 and 7. So it clearly implies that all 4 of these digits should be used. So it could be either 2, 5, 6, 7, or it could be 5, 2, 6, 7, or it could be 6, 5, 2, 7 or like that. Okay, so all 4 digits will be used in these places. So which are the possible ways of filling or making 4-digit numbers using all the 4 digits? It will be 4 into 3 into 2 into 1. We know permutations and combinations, right? So we are making use of permutations and combinations here, Okay, it is an arrangement without repetition. So first place can be filled by any one of these 4. The second place can be filled by remaining 3. The third place can be filled by the remaining 2, and finally one number which is left will be placed here. So there will be only one way. So finally we have 24 different ways of forming numbers. So therefore 24 numbers. Okay. Now for the 4-digit number to be divisible by 4, the condition is, or the divisibility test says that the number is divisible by 4 if the last 2 digits, the number formed by the last 2 digits, is divisible by 4. Okay, so we can clearly say which are the numbers which are divisible by 4, 2-digit numbers which are divisible by 4 formed by using these 4 digits. So they are 52, 56, 72 and 76. So the numbers could be one of these two. Okay, and now these 2 places are empty. So here 52, 56, 72 or 76 occupy the last 2 places. No other number can be divisible by 4. Okay. Now the first 2 places can be filled. These 2 places can be filled in by 2 numbers in 2 ways. Same way these 2 places can be filled in 2 ways. Same way here, same way here. So there are 4 different possibilities. Okay. So therefore 4 into 2 will give you 8 numbers which are possible. So finally the probability of the event A, what is A? A is the event that a 4-digit number comprising of 2, 5, 6 and 7 will be divisible by 4. This is event A. So then probability of A will be equal to 8 divided by 24, which is equal to 1 by 3. So hope you are clear with this next question. The next question is question number 6. A committee of 7 members is to be formed. A committee of 7 members is to be formed. Okay, a committee of 7 members is to be formed out of a group. Okay, from a group comprising of 8 gentlemen and 5 ladies. A committee of 7 members is to be formed from a group comprising of 8 gentlemen and 5 ladies. What is the probability that the committee would comprise of 2 ladies and at least 2 ladies? These are the 2 questions. Okay, first thing, when we have 8 gentlemen and 5 ladies and we need to prepare or form 7 members. So there are total 8 men and 5 ladies. Okay, so we have 8 men. We have in total 8 men and 5 ladies. Okay, and 5 ladies. So in total we have 13 people. Okay. We need to form a group of 7 out of 13 people. Okay, this can be done in 7 people out of 13 people can be selected in, see, a 7-member group can be formed from 13 people in 13C7 ways. Okay, and 13C7 will be equal to, we know the rules of permutations and combinations, right? So 13C7 will be equal to 13C 13 minus 7. Okay, it is 13C 13 minus 7. What is 13 minus 7? So it is 13C6, which is equal to, say, we can simplify this thing as 13 into 12 into 11 into 10 into 9 into 8 divided by 5, 4, 3, 2 and 1. Okay, this can be further simplified as 5 into 2 is equal to 10, and then we have 4 into 2 is equal to 8. Okay, then we have 3 into 3 as 9, and then we have 3 into 2 equal to 6. So finally this becomes equal to 13 into 12 into 11. Okay, 13 into 12 into 11. Okay. Now we shall take up the first case. This is the total number of ways. Total number of ways. Okay, number of ways. Total number of ways of selecting 7 people out of 13 people. Okay, 7 people out of 13 people. It is 13C7, which can be given like this. Okay. Now we will not multiply here. We shall simplify it later on. Okay. Now in the first case, that the group should contain 2 ladies. It should contain exactly 2 ladies. Okay. The first case is that the group should contain, or the committee should contain or should be formed of 7 members. Okay, but of which 2 are ladies. Contain 2 ladies. Exactly 2 ladies. A committee should contain 2 ladies. Okay, so the committee can be formed in how many ways? So first thing, 2 ladies and 5 men will form 7 people. Okay, 7 can be obtained as 2 ladies plus 5 men. Correct. So this will be 2 ladies and 5 men. Okay. So this will be this can be done in, say, 2 ladies out of 5 ladies. So it can be 5C2 into see, it is and 5 men. So 5 men means out of 8. Okay, 8C5. This can be further simplified. 5C2 will be equal to 5 into 4 divided by 2 into 1 multiplied by 8C5 will be equal to 8C3, which will be 8 into 7 into 6 divided by 3 into 2 into 1. Okay, so 8C5 will be equal to 8C3, and so this can be further simplified as 2 into 2 is equal to 4, 3 into 2 equal to 6. So when you multiply, this is 5 2s are 10 and 7 8s are 56. So it is equal to 10 into 56 ways. Okay. So therefore now what is the probability of getting or forming a 7-member group having only 2 ladies? So that will be equal to probability. Suppose if this is the event A, then we can say that probability of A will be equal to this one. Okay, this will be equal to 10 into 56 divided by 13 into 12 into 11. This is 13 into 12 into 11, which can be further written as 140. So after simplification, 140 divided by 429. 429 ways. This can be the answer. Okay. The next question is B, at least 2 ladies, that it should contain 2 or more than 2 ladies. So it is at least 2 ladies. Second question is committee has at least 2 ladies. See, it is at least 2. So it is 2 or more. Okay. So which are the different possibilities that can have? Okay. So it will be the 7-member can be formed by having, say, at least 2. It is so 2 or more. So 2 ladies and 5 men, or it could be 3 ladies and 4 men, or it could be 4 ladies and 3 men, or it could be 5 ladies and 2 men. Okay, these are the only possibilities, because at least 2, but there are only 5 ladies in total. So therefore, we can have only at the most maximum 5 ladies. So therefore, these are the possibilities. So 2 ladies plus 5 men, or, so this is or, okay, or, okay. So therefore, 2 ladies plus 5 men, or we have this case, or we have this case, or we have this case. So whenever we have or, we will add, whenever we have and, we will multiply. So this is 2 ladies and, this is and, okay. Instead of writing plus here, I can write, it can be formed by and, okay. 2 ladies and 5 men, this is and 5 men, and so 2 ladies and 5 men, 3 ladies and 4 men, or 4 ladies and 3 men, or 5 ladies and 2 men. These are the possibilities. So therefore, this can be written as, this can be done in how many ways? This can be done in how many ways? Okay. So 2 ladies and 5 men. We have just done here. So 2 ladies out of 5 ladies. So it is 5C2 into, and means multiplication. So this is 5 men out of 8 out of 5, sorry, 5 out of 8, or means like this, 3 ladies, okay, it is 3 ladies out of 5 and 4 men out of 8, okay. So same way, 4 ladies out of 5 and out of 8, we will be selecting 3 men, and sorry, or it is 5C5, all the ladies multiplied by 2 men out of 8. Okay, this can be simplified. Okay, we know how to put these values, and once we simplify all these values, so this can be written as, say, this is 5 into 4 divided by 2 into 1 into, this is 8C5 is equal to 8C3. So it is 8 into 7 into 6 divided by 3 into 2 into 1 plus, this is 5C3. Okay, this is one part. This is 5C3. 5C3 is equal to 5C2 again. Okay, so it is 5 into 4 divided by 2 into 1 into 8C4 is equal to 8C4. So it is 8 into 7 into 6 into 5 divided by 4 into 3 into 2 into 1. Okay, so this can also be simplified. Then plus this part will be written as 5C4 is equal to 5C1. So it is equal to 5 into 5C1 is equal to 5. Okay. So this is equal to 8C3 is equal to 8C3. So it will be 8 into 7 into 6 divided by 3 into 2 into 1. So that part is also over. Then we have 5C5 is equal to 1 into this is 8C2. So it is 8 into 7 divided by 2 into 1. Once we simplify all these, what we get is 1586 ways. So it is equal to 1586 ways. Okay, the final calculation will be 1586. Now what we have is the probability of event B. Okay, let me take this as event B. Okay, so then B will be equal to 1586 divided by 11 into 12 into 13. Okay, that is the total ways, 11 into 12 into 13 or 13 into 12 into 11, total number of ways of selecting 7 people. So this will give you probability of event B will be equal to 392 after simplification, 392 divided by 429. Here clearly numerator is less than the denominator. Okay, probability should be less than 1. So this is your answer. Okay, so both the cases, the committee should contain 2 ladies and the committee should contain at least 2 ladies. These are the 2 cases. Now let us look at the next question, question number 7. In question number 7, what we have here is, look, the following data relate to the distribution of wages for a group of workers. The wages are given in classes, that 50 to 60 rupees 15 people, and the 60 to 70 rupees are received by 23 people, and so on. This is the highest is 120, 110 to 120. It's a range given. So if a worker selected at random from the entire group of workers, one worker is selected at random, okay, from the entire group of workers. So how many workers are there in first? That is what we need to know. So finally, there are say 15 plus 23 plus 36 plus 42 plus 17 plus 12 plus 5 is equal to say 150 workers. Okay, this is 150 workers. So when we are selecting one out of 150, so total number of workers is 150. So first thing, how many workers, means one worker is selected at random from the entire group. What is the probability that his wage would be less than 50? So how many people are getting less than 50? See, it is 50 or more, right? Very clearly it is 50 or more. So it is less than 50 is nobody. So it will be 0. It will be 0 divided by 150. So probability that his wage would be less than 50. Probability will be equal to, if this is A, probability of A will be equal to 0 divided by this will be equal to 0. Okay, there are no people getting less than 50. Next, his wage would be less than 80. Less than 80 means it could be 50 to 60 or 60 to 70 or 70 to 80. So these people, it will be these people. Okay, so this can be written as probability of B. So suppose if this is B, then probability of B would be equal to 15 plus 23 plus 36 divided by 150. So we can add them up. When we add them up, this is 15 plus 23 plus 36 will give you 74 workers. 74 divided by 150. We may simplify if needed, or we shall keep it as it is. For the simplification, we shall give 37 divided by 75. Just divide by 2. That's it. Now his wage would be more than 100. More than 100 will be like this here. 100 or more. Okay, it is 100 or more is either 12 to 112 and 5. Okay, it is 100 to 110 and 110 to 120. So it is 12 plus 5 is 17. So we have probability of the event C as 17 divided by 150, which will give you itself. Okay, we are not further dividing. Okay, now the next case is between some points. So it is 70 to, the range is between 70 to 100. Let us look into the diagram. 70 to 100. 70 to 100 will see 70 or more, but less than 100. So in that case, we need this region. Okay, these many people. More than 70, but less than 100. Okay, so 70, it could be 70 to 80, 80 to 90, or 90 to 100, not the other classes. So it is 36, 42 plus 17. Okay, so probability of the event D, let me take this as D. So it becomes 36 plus 42 plus 17 divided by 150. This will go up to, we can get it as 95 divided by 150. So this can be divided by, so 19, 5 is a 95, and here we have is 30. So this is your answer. The next question, question number 8. 3 events A, B and C are mutually exclusive, exhaustive and equally likely. 3 events. So if we have 3 events A, B and C, so what is the probability of the complementary event? So what is the probability of A? A will be 1 by 3, B will be 1 by 3 and C also will be 1 by 3. See, the total amount will be 1. Okay. So now this is probability of A, probability of B, and probability of C. So all of them are equally likely, and they are mutually exclusive and exhaustive also. So what will be the probability of the complementary event of A? Okay, probability of A dash will be equal to 1 minus probability of A. Okay, that is equal to 1 minus 1 by 3, and that is equal to 2 by 3. Okay, or we can say that what is the probability of getting B and C. It is also one way. Okay, directly 1 by 3 plus 1 by 3 will be equal to 2 by 3. Okay, so that is 2 by 3. Next question, question number 9. Question number 9. In this, a number is selected from the first 25 natural numbers. Okay, a number is selected from the first 25 natural numbers. So that can be done in 25 ways. So total number of ways is 25. Okay, so n in this case will be 25. One number out of 25 numbers can be selected in 25 different ways. Okay. What is the probability that it will be divisible by 4 or 7? So first of all, numbers divisible by 4, and we shall write numbers divisible by 7. Let us write down the numbers divisible by 4 and 7. List down. Okay, so that will be, say, this is 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, and then 24. These are the only numbers which are divisible by 4 between the first of 25 natural numbers. Okay, now which are the numbers which are divisible by 7? Numbers divisible by 7. 7 1s are 7, 7 2s are 14, 7 3s are 21, 7 4s are 28, which is not there. So only 3 of them are there. So now we can say that what is the probability that it would be divisible by 4 or 7? So this is, if suppose this is set A, if this is set A and this is set B. Okay, this is set A and this is set B. Okay, or sorry, I should write it like this. Okay, now what is the probability that it would be divisible by 4 or 7? 4 or 7. So it will be probability that it would be divisible by 4 or 7. Okay, it is 4 or 7. So it is probability of A union B. So in A union B, any common elements? No. So how many elements? Which are the elements? Probability of A union B will be equal to number of elements in A union B. It is 1, 2, 3, 4, 5, 6, 7, 8 and 9. So it is 9 divided by total numbers, that is 25. So this is your answer. It is 9 by 25. Next question. Okay, a number is selected at random from the first 1000 natural numbers. What is the probability that it would be a multiple of 5 or 9? So first thing is that there may be many multiples of 5. There are many multiples of 9. So we need to first of all list them. So there are totally n will be equal to a number of elements in the total is 1000 natural numbers. So it is 1000 natural numbers. Okay. Now multiples of 5. Number of multiples of 5. Number of multiples of 5. So let us check that. So let me divide 1000 divided by 5 will give you 200. So there are 200 multiples of 5 which lies between lies from 1 to 1000. First 1000 natural numbers. Same way, which are the multiples of, this is 200. Then number of multiples of 9, that can also be done. This is 1000 divided by 9. 1000 divided by 9 will be something like 9 ones are 9. Say 100 point something. 1000 divided by 9, it is 111 point something. It is approximately, so we'll take only complete numbers. Okay, so it is 1000 will give you 111 point. This is 111.1111 and so on. So the number of multiples of 9 will be the integer part. It is the integer part, that is 111. Okay. Now there are some common multiples of 9 and 5. For example, 45. Okay. So like that, and 450 is also multiple of 9 and 5. Same way we can have many more multiples. So let us count the number of multiples of both 4 and means 9 and 5 of 45. Let me consider number of multiples of 45, that is both 9 and 5. Multiples of both 9 and 5 will be multiples of 45. So that will be 1000 divided by 45. So let me try that out. Divided by 45 will give you 22 point something, will give you 22.222 and so on. So we will be taking only the integer part, that is equal to 22. Okay. So we know that what is the probability that it will be multiple of 5 or 9? It will be, if the say multiple of 5 we take it as say set A, multiple of 9 we take it as set B. What will be this? This will be A intersection B. Okay. This is number of elements in A intersection B. This is number of elements in set B, and this is number of elements in set A. So what we need to find is probability of A union B. Okay, it is A union B. So number of elements in A union B will be equal to number of elements in A plus number of elements in B minus number of elements in A intersection B, because that is the number of elements which we have counted twice. So here we have, this is 200 plus 111 minus 22. So the total is as 200 plus 111 minus 22. So it will be equal to, 289. Okay. So the probability. So finally the probability of A union B will be equal to, probability of A union B will be equal to 289 divided by 1000. Okay, 289 divided by 1000 is 0.289. Okay, or we can say approximately equal to 0.29. Okay, it is 0.289. Next question. The next question is question number 11. The probability that an accountant job applicant has a BCom degree is 0.85. So probability that an accountant's job applicant has a BCom degree is 0.85, and that he is a CA is 0.30, and he is both BCom and CA is 0.25 out of 500 applications. So there are n is equal to 500 applications. Okay. Now if this BCom degree is taken as A, having a CA is taken as B, then probability of A is given to us. Probability of A is equal to, see, the probability of A is given to you as 0.85, and probability of B is also given to us as means of being a CA, that is 0.30, and that he is both means it is A intersection B. So probability of A intersection B is also given to you as 0.25. Okay, so out of 500 applicants, and n is equal to 500, how many people would be BCom or CA? How many people will be BCom or CA? Here we are supposed to find out the expected frequency, either BCom or CA. Okay, so let us first of all find out the probabilities. Okay, so we have P of A, P of B, and P of A intersection B. So what is P of A union B? Okay, probability of A union B. What is probability of A union B? It is equal to probability of A plus probability of B minus probability of A intersection B, which is equal to 0.85 plus 0.30 minus 0.25. That will be equal to 0.90. I hope, yes, this is 0.5 and 0.5 will be added here. 0.05. So 0.05 will be this. Okay, so it is 0.90. Now the total number, how many would be BCom or CA? Probability that an accountant's job applicant has a BCom degree, has a CA degree, or both, or none of these. Okay, none of these cases are also there. So therefore, expected frequency will be equal to 0.90 into total frequency. Okay, it is probability into n. So it is 0.90 into 500. So this will be 9 5s are 45, 450. Okay, so therefore, how many would be BCom or CA? It will be 450. So you need to remember this part, that this is expected frequency. Here we are asked a number of people. Okay, number of people who could be BCom or CA. Okay, let us understand that by the Venn diagram. Suppose these are the total 500 candidates. So there are some candidates who are CA. There are some candidates who are BCom, there are some candidates who are CA, there are some candidates who are both of them, and there are some candidates who are none of them, but they have applied. Okay, like that. So what is the total number of people who are both of them? Okay, the number of people in A union B is asked. Expected frequency will be equal to number of elements in A union B. This is asked. Is that clear? Fine. Let us move on to the next question, question number 12. Question number 12 is, if P of A minus B is given to you as 1 by 5 and P of A is also given and P of B is also given, what is the probability of the two events? Probability that out of the two events A and B, only B will occur. What is the probability that only B would occur? Only B means it is P of B minus A. Only B means it is P of B minus A. Only B. Only B means it is equal to probability of B minus A. That we are talking about only two events, A and B. Okay. So what is P of A minus B? P of A minus B will be equal to P of A minus P of A intersection B. It will be equal to P of A minus P of A intersection B. Okay. So therefore, what is P of A minus B? P of A minus B is given to you as 1 by 5. What is P of A? P of A is 1 by 3. So it is minus P of A intersection B. So we can find out P of A intersection B from here. Intersection B. P of A intersection B is 1 by 5. It is 1 by 3 minus 1 by 5, which will give you, this is 5 3s are 15 and this is 5 minus 3, this is equal to 2 by 15. Okay. Now we shall use that for P of B minus A. What is P of B minus A? P of B minus A will be equal to P of B minus probability of A intersection B. Okay, only B. Okay, this is A, this is B, this is A, this is B. Only B means this part. It is B minus A intersection B. Okay, so that will be equal to, what is probability of B? It is given as 1 by 2 minus probability of A intersection B. A intersection B is 2 by 15, which will be equal to, we can simplify as this is 30. This is 15 minus 4. So it is 11 by 30. Okay, the value is 11 by 30. Hope you are clear with the topic here. Next, let us move on to the next question. Here in question number 13 is a long question. There are three persons. There are three persons A, B, and C having different ages. The probability that A survives another 5 years is 80% or 0.80, and B survives another 5 years is 0.6. C survives another 5 years is 0.50. Okay, so let me write this as P of A is equal to 0.80, P of B is equal to 0.60, and P of C will be equal to 0.50 as per given. Where we assume that A is the event that A survives for 5 years, B is the event that B survives for 5 years, and so on. Okay, now the probability that A and B together survive another 5 years is 0.46. So let me take this as A intersection B. Probability of A intersection B is equal to 0.46. Then we have B and C survives together. It is a probability of B intersection C, because together, okay, it is 0.32. And we have probability of A intersection C or C intersection A will be equal to 0.48, and that all these three people survive another is 0.26. That is probability of A intersection B intersection C equal to 0.26. Find the probability that at least one of them survives another 5 years. At least one means either A or B or C or any two of them or all three of them. So it is actually, we are talking about probability of A union B union C. It is at least one of the three or all of the three or any two of the three. Okay, so this will be equal to, we know the formula, P of A plus P of B plus P of C. Okay, P of A plus P of B plus P of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. So this, all the values can be put in. This is 0.80 plus 0.60 plus 0.50 minus 0.46 minus 0.32 minus 0.48 plus 0.26, which further, after simplification, after simplifying all of them, what we get here is 0.90. Okay, so probability that at least one of them survives another 5 years is 0.90. Next question is CPP number 14. So it is, Rupesh is known to hit a target 5 out of 9 shots, while David is known, okay, let me take the probability of Rupesh is equal to 5 out of 9, and the probability of David is equal to 6 out of 11. Okay, so it is 6 out of 11 shots. What is the probability that the target would be hit once they both try? What is the probability that the target would be hit once they both try? It would be hit means either it is hit by Rupesh or David or both. We can say that it has been hit at least once. Okay, so once or both of them have hit it. So here we can see that they are independent events. Okay, clearly the performance of Rupesh is not affected by that of David, and the performance of David is not affected by the performance of Rupesh. So they are independent events. So we know that probability of R intersection D will be equal to probability of R into probability of D. Okay, so we know this. So this is equal to 5 by 9 into 6 by 11. Okay, this can be further simplified. 6 5s are 30 and 11 9s are 99. This can be divided by 3. So 3 3s are 9 and 3 3s are 9, 3 10s are 30. So it is 10 by 33. So here A and B, or sorry, R and D are independent. Okay, here R and D are independent. Okay, so we know this now. Now probability of R union D. Okay, they hit the target at least once. They hit that, either the target is hit by Rupesh or it is hit by David. So that will be equal to and that will be equal to probability of R plus probability of D minus probability of R intersection D, which we have found out as 10 by 3. So, we shall put the values. This is 5 by 9 plus 6 by 11 minus probability of R intersection D is 10 by 33. This can be simplified. And what you get here is 79. It is 79 divided by 99. Okay, 79 by 99. So, the target will be hit. The probability that the target will be hit will be equal to 79 by 99. Now, let us look at question number 15. So, here a pair of dice is thrown together and the sum of points on the two dice is noted to be 10. What is the probability? Okay, the sum of points on the two dice is noted to be 10. So, our sample space will be restricted sample space, and for our simplicity we can see that or mark that this is 10, this sum will be 10, this sum will be 10. No other points will give you, no other combination will give you a 10. Okay, so the list is this is 4, 6, then we have 5, 5 and we have 6, 4. Okay. Out of them, A will be the event of getting a 4. Okay, event of getting a 4 as one of the points. So, it is either 4, 6 or 6, 4. So, there are two options. A will be 4, 6 and 6, 4. Okay, these are the two possibilities which can give you the sum 10 as well as a 4 in it. Okay, so therefore, what is probability of event A? It will be equal to 2 out of the 3. Okay, 2 out of 3. So, our problem is solved. Fine. Okay, we shall take the remaining 15 questions in the next class. Okay.